In front of us are the most important terms in electrical engineering and electricity in general. They are electric current, symbolized by I, voltage or potential difference, symbolized by V, power, which we call power, and R, which is resistance. These are the basics we need to understand and build upon in the world of electricity. The first point, as we mentioned in the previous lesson, is that electricity is essentially electrons that we push using energy. We move them out of the atom's outermost orbit. The easier it is to free the outermost electron in the nucleus of a conductor, the higher the conductivity of that material. One of the most famous conductors we have is copper. So if we have a piece of copper like this, we need a source of energy to free the electrons inside this conductor, and their number is in the billions of billions. This energy source could be kinetic energy, as we will study later, or a chemical source, like a battery. This is the symbol of a battery in electrical circuit diagrams, and its job is to provide the voltage difference we need. Once a voltage difference exists, the electrons are freed and move along this path. As we saw, the actual motion of electrons is from lower voltage to higher voltage, but in calculations, we do the opposite, from higher voltage to lower voltage. This is where the term conventional current comes from. So now we know that electric current is essentially a stream of electrons. The second point is, how do we measure this current? Since we are dealing with billions of electrons, and we already know that in calculations, the direction is always from higher voltage to lower voltage. To avoid writing numbers in the billions, we use the unit called the Coulomb. 1 Coulomb equals that enormous number, billions of electrons. If we calculate how many coulombs pass per second, we get the unit of electric current, which is the ampere. 1 ampere equals 1 coulomb per second, which equals that number of electrons passing per second. So now we understand how electric current is generated and how it is measured, and we also know that we need a voltage difference to free the electrons and produce electric current. Next, we have resistance. Every material has resistance. Even copper, which is a conductor, has resistance, but it is very small. Resistance always opposes electric current. The higher the resistance, the lower the current, and vice versa. This is Ohm's law, which states that voltage equals current multiplied by resistance, or we can say that electric current equals voltage divided by resistance. So the relationship between current and resistance is inverse. We notice that as the resistance in the denominator approaches zero, the current tends toward infinity. This is why a battery produces sparks. If we directly connect the positive and negative terminals with a wire, without connecting a bulb or any device in between. That's because the resistance of the wire is very small, approaching zero. When we substitute this into the equation, the current goes to infinity, and the sparks appear, what we call a spark. Finally, we have power. This is the number we see written on electrical devices, and we will explain it in detail in the next lesson.